On a cold Christmas morning in 1642, in the tiny hamlet of Woolsthorpe, England, a frail baby was born prematurely. No one expected him to survive. But against all odds, this child, named Isaac Newton, grew up to change the world forever. His journey from a quiet boy in rural England to one of the greatest scientists in history is a tale of relentless curiosity, determination, and extraordinary intellect. The lonely boy Isaac Newton's early years were far from easy. His father died before he was born, and his mother remarried when he was just 3, leaving young Isaac in the care of his grandparents. Lonely and introspective, Newton found solace in tinkering and building. He constructed windmills, water clocks, and even a tiny working sundial. At school, Newton wasn't initially an outstanding student, but a confrontation with a bully changed everything. Determined to outdo his rival, Isaac threw himself into his studies. This newfound focus revealed his brilliance, and he quickly rose to the top of his class. A young scholar at Cambridge. At the age of 18, Newton entered Trinity College at Cambridge University. It was here that his genius began to blossom. Newton immersed himself in the works of great thinkers like Aristotle, Descartes, and Galileo, but he often found their explanations lacking. He began to ask his own questions and seek his own answers. In 1665, when the Great Plague struck England, Cambridge closed its doors, and Newton returned home to Woolsthorpe. During this 2-year period of isolation, often called Newton's miracle years, his mind worked tirelessly. It was here that he began to lay the foundations of calculus, explored the nature of light and optics, and formulated his idea in the English countryside in the mid-1660s. A young Isaac Newton, a recent graduate of Cambridge University, had returned to his family home in Woolsthorpe Manor. The Great Plague was sweeping through England, forcing universities to shut down. This unexpected isolation turned out to be a blessing in disguise, as it gave Newton time to think, observe, and ponder the mysteries of the universe. One day, as Newton sat under the shade of an apple tree in the garden, lost in thought, he saw an apple fall to the ground. It wasn't an unusual sight, but Newton's sharp mind turned this everyday occurrence into a profound question. Why does the apple fall straight down? Why doesn't it move sideways or upwards? What is pulling it to the earth? He considered how the apple was not unique. Every object he had ever seen fell to the ground. This force seemed universal. But Newton's mind didn't stop there. He looked beyond the apple, beyond the garden, and up to the heavens. He wondered, could the same force that pulls the apple to the earth also extend to the moon, holding it in its orbit? This was the spark that ignited Newton's revolutionary ideas about gravity, connecting the dots, the moon and the apple. Newton began to think deeply about the motion of the moon. Why didn't the moon simply fly off into space? He knew that objects in motion tended to move in a straight line, unless acted upon by a force. This was an idea he was already working on, later known as his first law of motion. Something must be pulling the moon toward Earth, keeping it in orbit. He reasoned that the same force pulling the apple to the ground might be acting on the moon, but on a much grander scale. What if gravity wasn't just a force confined to Earth, but extended far out into space, reaching celestial bodies? Newton imagined a cannon on a high mountain. If it fired a cannonball with enough speed, the ball would travel so far that it would fall around the Earth rather than straight down. This was the essence of orbit, a balance between the pull of gravity and the forward motion of the object. The moon, he realized, was like a giant cannonball, constantly falling toward Earth, but never hitting it because of its sideways motion. The mathematics of gravity Newton didn't stop with these imaginative ideas. He worked tirelessly to prove them with mathematics. He started thinking about how the force of gravity might weaken with distance. Inspired by earlier work from astronomers like Johannes Kepler and Galileo Galilei, he tested the idea that gravity followed an inverse square law, that its strength decreased with the square of the distance. This was a moment of triumph. Newton realized that if the force of gravity followed this rule, it could explain both the falling apple and the orbiting moon. The same mathematical principles that described the motions of planets around the Sun, as discovered by Kepler, could now be derived from a single universal law. Years later, in 1687, Newton published his findings in a monumental work, the Philosophiae Naturalis Principia Mathematica, or simply the Principia. In it, he formulated the law of universal gravitation, stating F equals sign GM1 M2/R2. This elegant equation showed that every object in the universe attracts every other object, with a force proportional to their masses and inversely proportional to the square of the distance between them. The legacy of the apple. Newton's ideas transformed our understanding of the universe. He unified the motion of falling objects on Earth with the motion of celestial bodies in space. The same force that caused the apple to fall also kept the moon in orbit and governed the motion of planets around the Sun. The story of the apple became legendary, though Newton later admitted that the falling apple wasn't a sudden eureka moment, but rather part of a long process of thought. The image of him sitting under the apple tree remains a symbol of human curiosity and discovery, reflection. Newton's discovery of gravity wasn't just about a falling apple. It was about asking bold questions, making connections between seemingly unrelated phenomena, and using the power of mathematics to uncover the laws of nature. The apple and the moon remind us that the universe, in all its vastness, operates on principles we can understand, if only we dare to look up. Newton returned to Cambridge and became a professor, but he remained a private and secretive man. He avoided fame and rarely published his work, yet his contributions were monumental. Calculus. Newton invented a new branch of mathematics to describe changing quantities. Though his methods sparked a bitter rivalry with German mathematician Gottfried Wilhelm Leibniz, calculus became a cornerstone of modern science. Optics. Newton used a prism to split white light into its component colors, proving that light was made of a spectrum of colors. The Principia. In 1687, Newton published his masterpiece, Philosophiae Naturalis Principia Mathematica. In it, he outlined the three laws of motion and the law of universal gravitation, providing a framework for understanding the natural world.